Are we waiting for others coming? Okay, good afternoon. Can you see my screen?
Yes, sir.
Okay, so
Afternoon.
Professor, so the morning said they help you to apply the educational accounts from Amazon, and there's some problems, so they need the time to take care of this. So he asked me to take the first hour. So the professor he get started his classes from the 2:30. Okay, so I continue to last day our the teachings about the decision model of investment. Yeah, so MPV, right? This one, right? Net present value. So Okay, I suppose for the one period time decision. So we know V1 division by 1 plus K. Okay, minus I, right? It's 1. V1 minus I outflow in V1 inflow and one period time. And during the time, you bear a risk compared to you have an opportunity to invest money on the risk-free rates or asset. Okay, so if we ask you to invest on the risky assets, you bear the more risk, and then you invest money on the risk-free security. Okay, so the K must be adjusted risk rate. Also, you can call it appropriate discount rate. And last 2 days, I not mentioned how to calculate K, right? Okay. So one famous method to calculate K, we use the model. The model is the capital asset pricing model. So asset pricing model tell the investors to how to evaluate the K. And we know if the investors invest money on the risk-free assets, they get a risk-free rate F. But you ask them to make alternative investment, they have to bear the most. So you need to give them more the return of rate, right? So here we call the risk premium. Risk premium, right? Yeah. Okay. In other words, you have to pay more return to attract investors invest their money on your project. Okay, so risk premium, how to calculate? Okay, by cap M. Okay, by cap M. Okay, risk premium. Okay, the beta. Okay, beta is the system risk and time market assets return. Okay, ERM minus IF. Okay, okay, the beta define as the covariance security I. Okay, actual return or correlation with the market return RM. Okay, and division market volatility standard deviation M square. Okay, that's your beta. Okay, yeah. So that means you invest your money on some security in stock markets, some security I, and like you invest money in the stock markets or invest money in the stock markets. The beta are different. Yeah. Okay. So if we can use the cap M to get K, the required rate returned by investors, we can get the present value, right? Okay, so this is one of the calculating the appropriate discount rate. Okay. Okay. Yeah. So another thing. Yeah. So some scholars challenge this. If we want we criticize to keep a model, and that means in some case, in some situations, that doesn't work. So how to get NPV? Yeah. So at this time, we use another model. Which kind of model? You know it. Okay. So last day, I mentioned three models, right? Step price model, risk neutral methodology, and duplicating portfolio. Okay, you use that to get NPV. Also can. And today I want to introduce the number 5. Okay. Number 5 is CEQ, or certainly equivalent benefits model. So we know the NPV is 1, right? V1 1 plus K minus I. Okay. The investment for the calculations for the one period time investment, right? Okay, so now if I not use the adjusted rate of return, okay, I substitute K by risk-free rate, RF, okay. Also, the investment is risky. I use the RF to be its discount rate, and in your denominator, you have to be changed, right? Because your discount rate, you change it by risk-free rate. So you have to change it V1 by something like that, right? Okay, so here V1 we change it by CEQ. Okay, CEQ. Okay, CEQ. Okay, CEQ change it over the your discount rate. Okay, this one. Okay, should be similar. So this method we call the CEV methodology. Okay, certainly equivalent. Okay, I forgot the Q, how to call it. Okay, so CEQ, CEV, sorry, CEV. Okay, here's CEV. Yes. Okay. Here is one important idea or concept you have got to know. So what's the idea or concept you have to know this? Don't forget your number in denominator relative to the number in numerator. Okay, so I mean the K relative to V1 RF relative to the CEV. Yeah. When you use the V1 and the number in your denominator should be the change, right? Also, you use the CEV in numerator, it should be changed, right, by RF. Okay. Okay, we call this the certainty equivalent. How to get it? This one. Okay, now I said that, okay, so this one, I derived from this, okay, this one. So this one, I said V1, V1, 1 plus K. I say is the Prism value, right? PV. Okay, I say it. And this one, CEQ1, okay, CEQ1, okay, division by RF, okay, another kind of the PV, right? Okay. Okay, so by this one, we know, okay, we know 1 plus K, okay, 1 plus adjusted rate of return equals the time of V1, PV1, a PV, right? Equals V1, right? Okay. And we know this one, the K by cap M can be rewrite as risk-free rate plus the beta I, okay, beta I ERM, okay. Okay, operator of expectation, okay, to the market return, okay, RM. Okay, the question say here. Okay, yeah, and okay, so we know the PV. Okay, so we know the PV1 PV, right? Equals 1 plus RF plus the beta RM RF, right? And take this potential. Okay. Okay, so the beta we know is covariance. Sorry. Covariance. Okay. Covariance Ri, right? So for some security Ri and Rm, right? Sigma m squared, right? Okay, and we know, sorry. So Ri here, Ri, this one, right? Ri, okay. This one, okay. So check this. So P, this one, the V1 division PV minus 1, right? Okay. So Ri is this one. So covariance P, sorry, and this one, the C1, okay. The C1, okay. Sorry, PV. This one is V1, right? So I is V1 V1 PV, right? Minus 1. Sorry, it's show here. Okay, covariance Ri is the V1 PV, okay, minus 1 Rm, right? Sigma m squared. Okay, by the covariance properties of the statistics, so we know the covariance V1 over PV minus 1 Rm can be right the covariance V1 PV, right? Rm sigma m squared. Okay, I ignore the minus 1. There is no influence on your covariance. Yeah, this is constant. This is deterministic number, so it's not a random. So you can ignore the minus 1. Okay. So like for example, okay, like covariance x plus 2 y. We can write it covariance xy, right? Okay, so because the constant 2 is not a random variable. Okay. Any questions here? No, right? Okay, so and this one, okay, this one equal. Okay, this one, the PV, I can move, right? From inside, move it to outside, right? So this one is PV here. I put here time sigma square. Covariance V1 Rm, right? Okay. Okay, so your beta here. So this one. So so beta at this one, I use this. Okay, so we know the beta is 1, right? You use the cap m covariance Ri Rm division by a sigma square, and you based on the relationship this one, so you can change it, right? So we use the beta covariance V1 Rm division PV sigma m square. Okay, so here, so we know, sorry, this one. PV sigma square. Okay, PV is the present value of project, and the covariance V1 Rm. Yeah. Originally, the beta is the covariance Rm and over the sigma m squared. But now the covariance is V1 Rm. Yeah, okay. A little different, yeah. Okay, and here, any questions? No, right? So I use this one. Okay, so we PV here. So here PV, right? We have a right PV. Here's PV, okay. Sorry. So the PV, all right. So PV1, okay, so this one. V1, I multiply both side equality by the PV. So and left hand side of the equality we get V1. Right hand side of equality we have the 1 plus RF PV, right? And plus, okay, PV here. So we left sigma m squared. Okay, here's PV disappeared because we time the PV on both sides of the equality. So we left the sigma m squared, and in your denominator the same covered with V1 Rm. Okay. Yeah. So now I move this this item from your right hand side equality into the left hand side. So V1 becomes V1 covariance V1 Vm, sorry, divided sigma m square, right? Yeah, equals 1 plus Rf PV, right? Okay, so PV, clearly PV we get from the equality 1 plus Rf V1 minus covariance V1 Rm. Okay, Rm. Okay. Here. Division by sigma m squared. Okay. So what is your certainty equivalent value? So this one, right? This one, right? Okay. 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 Yeah, so this one you will see certainty equivalent value, this one, right? So V1 minus covariance COV, okay, V1 market return RM division sigma M squared. Okay, yeah, this is our number 5 price model. Yeah, yo, it why we use the model to price is there is one advantage. What's the advantage? We don't need others. We just know the RF risk-free rate. We don't need to get the risk premium from the complicated model. We don't need, right? So we can calculate the present value, right? We just use the V1 minus the covariance and the over the sigma M squared. Okay. Yeah. So this is our number 5. So any questions? All right. Okay. It's a different risk neutral methodology model. Last day we mentioned the risk neutral model. We ask all the securities in financial markets traded their expected rate of return should be equal to RF, right? Okay, so contrast to the risk neutral model, the CV model. Okay, so risk neutral model tell us about the price, right? Okay, sorry, the price. Okay, risk neutral model price should be equal to probability pi, right? Right. Your price, the up, right? PU up plus the 1 minus pi here, right? PD. Okay, D is your down the in the down state, right? And this is your expected value. Okay, and you have to discount, right? We use the risk-free rate, right? So here, okay. So the model, risk neutral model, methodology model. So some part same with the CEV model here, right? But it's a denominator, so it's different. Okay, so yeah, so it's I told you what you have to remember. Okay, that's not all the same. Yeah. Okay, so there are 5 models in finance. It's very, very important to evaluate asset value. Okay. Any questions? All right. Okay. Sorry. Yeah. Okay. So next. Okay. So next, in first state, I use time to introduce strategy analysis, right? There are 3 strategies. First one, industry industry analysis, right? The second one is competitive strategy, right? Last one is corporate strategy, right? Okay, so by case, you can use one of these three the strategies to analyze and analysis over the financial decisions or investment decisions. Yeah. Okay. So remember, for the first strategy, they are based on the five forces, right? Rivalry, potential, and substitute, and bargaining power from the customer, and bargaining power from the supplier, right? So five forces to drive the 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 profitability of industry, right? Okay, so yeah, so competitive strategy based on the cost and differentiation, right? Okay, so cost leadership means that you can use the cost, the advantage to beat your opponents, right? Okay, and like your the market share increase, right? Okay, so the last strategy, corporate strategy. They're based on the transaction cost. Yeah, transaction cost. Their advantage built on the inside communication advantage larger than the outside information cost. So they have the incentive to all merge in one, right? Okay. Okay, so why I mentioned the analysis in our first day, because I want to induce the competition, okay, competition and investment with real action model. Okay, so you have to, yeah, real action model is good, the tool. Yeah, you not use the tool. You sometimes you need some theory to support you using this model. Yeah, and after that you can write a good article. Yeah, so okay, any questions? No, right? Okay. Let me I sent papers, right? There are three papers. The first papers talk about the competition and investment. Yeah. Okay. You can open it. Yeah. All right. Okay, so the paper claim the competition will reduce the future profits and therefore delay the future investment. So the paper not only consider one player in industry, but also consider two players. Okay, two players industry. I'll say, okay, we know the one player industry we can call this monopoly, right? And two players industry you can call that oligopolistic games, right? Okay, so the paper and other things you have to know. The paper not only the real action model tool, they also use the game theory. Yeah, game theory. Okay, so last day I mentioned the option, this one, right? You have the way to invest you have the way to abandon, right? Okay. Okay, so the paper use the last day I talked about the two kinds of reactions to price and describe the players how to interact each other. Okay. Okay, so the paper, yeah, that's the authors. The suppose there are two players. Okay, there are two players. Okay, two players. Okay, two players, right? I opened it. This one. Okay, this one, the paper. Okay, two players. I guess let you know. Okay, two players in the dart tree. Yeah, and and one player is the leader, another one is the follower. Okay, right. Yes. Okay, so here, and the leader and follower, so it's a profit flow given by this. Yeah. Okay, so when the n equals 1, okay, the profit flow is yd1. Okay, and n equals 2, the profit flow is yd2. Okay, so d1 is not equal to d2. D1 means the situation is in the monopoly, just only one player over there. So is the profits flow more than there are two players, right? Okay, so D1 not D2, and the D1 uh, uh, D1 is the D2. Okay. Okay. And here Y, we suppose it follow a geometry Brownian motion. So last day I talked about this process, right? Okay. Yeah. Okay, so last day I said you have to find the criterion to let you can judge when is the best timing you can invest or wait, right? So here, equation 1, y is you have to find a y star. Okay, so here y use I use the y2. Y2 means there are two players. There are two players in the dart tree. Y1, okay, here Y1, okay, Y1 means just only one player. Okay. Yeah. Any questions? No, right? Okay. So this one. So we have to find the criterion for the two players, right? Okay. The beta division beta minus 1. Last class I mentioned, right? Okay, the same. The same, right? So here, because we use the pi equals the ydn. So last night, remember the formula? The pi is pi, right? Not it's not decomposed into the two parts, right? Well, pi is pi, right? Okay, by for this paper, the authors decompose it into two parts. Okay, so two factors drive the private flow. Okay, but that's class we not use the pi. Okay, not decompose it into two parts, right? Okay, so that's fine, yeah. So you can move the d here. Okay, d here is your pi, right? D times y is your pi, right? Okay, so they just move the d into here. Okay, yeah. Okay, so okay, we can use the value matching condition and the smooth passing condition to find out equation one. Okay, today no time to prove this. Okay, maybe in another day I prove it. Okay, yeah. Okay. Sorry. Okay. Yeah, and okay, so two players, right? Okay, so at this moment, player two, okay, follower, okay, I call a player to the followers, okay, follower executes is action, right? These two, right? Yeah, and why the so we use the backward method to infer who execute, who firstly execute is the action. So follower as we know the leader execute, right? The firstly execute is action, right? Okay, leader. Okay, but we use the backward, right? So this at the moment y2, when the y, okay, y2, these two players in the dot tree, right? Okay, in the dot tree, right? Okay, okay, y is this y2, and this one, okay, is the period just only leader, right? Only one, right? Only one, right? Okay. Okay, because the you ask why you ask a follower to execute is action to enter the industry, they have to check the private flow can cover its cost, right? Okay, yeah. So during the time interval, just only one player, okay, who is the leader, right? Okay, okay. So at this period time, the private, okay, the leader get all right. Okay, so we use the D1, okay, D1, and this after this, it's a private the industry share with player one and player two, right? And okay, leader and the follower, right? Okay, two players to share, okay, to share the private profit flow, right? Okay. So you have clarify which situation only one player can take over, which situation two players share the profit floor. Okay, yeah. So this one. Okay. Okay, we back the paper. This one. Okay. So so for the criterion Y2, player one and player two, okay, leader and follower, they enter the dot tree, compete with each other. Okay. Yeah, the beta is the root. The last class I mentioned how to compute the beta, right? The same, right? The method is same. Okay, so and we know the follower, the value is the I minus and your value after you execute the actions, the value yd2 over delta. So here the function of the number of players. Okay, so the number is 2. Yeah, and otherwise the y not exist the y2, that does mean the not enough the profit to attract player to a follower to enter. So here it's the profit that is. Okay. Okay, so you can check the follower invest immediately and obtaining the expected discounted value. Okay, of future to operate profit flows from complete investment. If the Y narcissist criterion, the follower waits until the Y2 is reached. Okay, the following value is the value of complement investment discount appropriately. Okay, so next we discuss the leader value. Okay, leader value, we check Y. Okay, so Y is just the Y2. Not only leader over there. At this time, follower will immediately enter in that tree to compete with the leader. So the total profit flow will be shared by two players, right? So here the profits for leader is a value same with the follower. They share each other. So the leader before he is in the monopoly, and this time becomes duopoly, right? Okay. Okay, so if the Y narcissist Y2, just only one player in the dot tree, so it's pay off this one. Okay, one time the one player, okay, type the D over the delta and minus option and minus I. Okay. Yeah. So so the papers just use as I said before, the paper used the real action model combined with the game theory to research the competition behavior in industry. Okay. Okay, you can check it, right? Okay, so equilibrium in some game perfectness equivalent, the strategy here. So Y1 is the leader. Is the criterion enter or not in that tree. So the Y not is the Y1, which means not enough the incentive to attract any player to enter the dot tree. Okay, so Y between Y1 and Y2, so just the leader invest and wait until the Y2s come in. Okay. So Y is this Y2, not only the leader, the follow the join. Yeah, okay. You can check, right? Okay. This is our first paper. And okay, the second paper. Sorry, let me check this one. Okay, the second paper, okay, they use the real actions model to discuss the agency conflicts and find out the optimal capital structure. Okay, so we know capital structure comprised the two players, right? One is the debt holder, another one is the equity holder. So the criterion we have to, which criterion we have to find? Firstly, so this kind of paper, the debt holder criterion, we have to find it. Why we have to find out the criterion for debt holder? We know in corporate finance, debt holder is they have the priority, right? Okay, so we have to take care of the debt holders. Okay, so this one is the section 2.2 is the pure. Pure means the no debt. Okay, all equity. Okay, so this 2.3, the lever means the some fundings from debt holder. Okay, so this one, their capital structure means by debt and equity. Okay, so this one. So you see, equation 6. They firstly find the PD. Okay, PD means the trigger price. Okay, criterion. Okay, criterions. Okay, the for debt holder. Yeah. Okay, we check. So this one. Okay, this is second paper. Sorry. Okay, this is the third paper. Okay, the third paper also discussing the capital structure, but let's get started from a behavior perspective. Okay, so they combine the psychology, manager, the psychology from the managers. We know that managers do some the couple policies overconfidence, right? So and to the investment administrative, right? So how do we use the parameters to stand for the managers overconfidence and optimistic? So and this paper, they use the expected return and the risk standard deviation. Okay, so you can check that. So you can find is the interesting the paper. Okay. Okay, I think it's time out. Later professor will to teach the fintech. Okay. So any questions? Okay, no questions. We take a rest. I told the professors. Okay, I done it. Okay. Okay, we take a rest. 10 minutes. Okay. 10 minutes. A break. Okay. Okay. Thank you.